Hello learners, I welcome you all to this teleconferencing session on mountain building theories. This is for our core course on physical geography, which is for a BSc general program with geography as one subject, and this topic is related to the second block, which is on lithosphere. So after viewing this session, you should be able to define mountains, distinguish between different forms of mountains, critically discuss the mountain building theory of Kober, and discuss the mountain building theory of Holmes, and distinguish between the above two theories. Although we have another theory, that is plate tectonic theory, which is also related to mountain building, but in this session we are covering only Kober's theory and the Holmes convection current theory, because it not only caters to the mountain building but also explains continental drift and various tectonic events. So we need a separate session on plate tectonics theory, and after this session we will take up that session. So now what are mountains? Mountains are significant relief features of second order on the earth's surface. Now what do you mean by second order, first order? Now in this figure you see that the landforms are divided into various orders. The landforms of first order are the continents and oceans, which is a broad division of the landforms, and then features of the continents or the oceans are the second order landforms. So mountains, plains, plateaus are the features of the continents and they are the second order. Similarly, in the oceans we have continental shelf, continental slope, ocean basin, deeps, which are the second order landforms of the oceans. Similarly, landforms of third order are peaks, cols, which are formed by more complex processes occurring in the second order landforms of both continents and oceans. So mountains are the significant relief features of second order on the earth's surface. Now there are several forms of mountains. These are the terminologies like mountain ridges, mountain range, mountain chain, mountain system, mountain group, which to a non-geographer it would be like similar terms, but being a geographer you need to differentiate between these terminologies and you need to be acquainted with them. So what is mountain ridges? It is a system of long, narrow, high hills. And what is mountain range? It is a system of mountains and hills having several ridges, peaks and summits, but all are of the same age. But in case of mountain chain, you see there are several parallel long narrow mountains, but they are of different periods. So you have to differentiate between, like mountain range are of the same period, same age, mountain chains are of different periods. Now what is mountain system? These are different mountain ranges of the same period, and mountain groups are several unsystematic patterns of different mountain systems, and cordillera are the most complex ones, that is the several mountain groups and systems forms cordillera. That means in a cordillera you will find several mountain groups, chains, systems, ranges, etc. Now coming on to the theories of mountain building, there are theories based on two types, like theories based on horizontal forces and theories that are based on the vertical forces. The theories that are based on the horizontal forces are again divided into two types, like those which are the contraction theories, like Kober and Jeffries were contractionists and they propagated the theory based on contraction theory. Now another type of theories based on horizontal forces was related to drifting of continents, like Taylor, Wegener. We have studied about drifting of continents or the continental drift theory of Wegener in the previous session, and in this session also you may recall that drifting of continents, while explaining the drifting of continents, Wegener had also explained the mountain building theory. Similarly, Holmes' convection current theory is also related to drifting of continents, and similarly plate tectonic theory is also based on the drifting of continents concept. Theories based on vertical forces are undulation and oscillation theories of Harton. But at this level, we are focusing more on the Kober's theory, Holmes' theory and plate tectonics theory. And in this particular session, we are dealing only with the Kober's theory and Holmes' theory. Now, coming on to the geosynclinal Orogen theory of Kober. First, you know some of the basic things, that Kober was a German geologist and he wrote a book Der Bau der Erde, in which he gave a systematic description of the earth's features. His theory, as I mentioned already, was based on the contraction concept, and this contraction concept was related to the cooling of earth, which due to which cooling the contraction of earth was there, and then a stress kind of force was generated, and this force was horizontal and it led to the formation of mountains. You will understand this better when I explain it with the help of figure. In the geological past, our globe was characterized by rigid masses and geosynclines. So, these rigid masses were the continental masses and geosynclines were long, wide, shallow water depressions characterized by sedimentation and subsidence. So, these geosynclines were bordered by the rigid masses that were also called forelands. Now, Kober defined the process of mountain building or orogenesis as the process which links these rigid masses with the geosynclines. Now, as I told you that geosynclines were long, narrow, or there was some differences between the geologists whether it was narrow or wide, but they were long, wide, shallow depressions, and which was characterized by sedimentation from the surrounding forelands, and after the sedimentation occurred, they put enormous pressure on the geosynclines, due to which they underwent subsidence, and this subsidence generated a stress force, due to which the forelands moved towards each other and the sediments in the geosynclines were squeezed, buckled and crumbled in the form of mighty fold mountains. So, this is the basic of the geosynclinal origin theory of Kober. Now, you need to know some of the terminologies, like surrounding rigid masses were also called cratogen by Kober, and these were like Canadian Shield, Baltic Shield, Siberian Shield. These are all the ancient land masses, Chinese Massif, Peninsular India, African Shield, etc. And he was of the opinion that mountains are formed from the sediments of the geosynclines. Now, dealing with the mechanism of the theory, Kober's theory takes place in 3 stages, like first is the lithogenesis, second is orogenesis and the third is glyptogenesis. Lithogenesis is the basic creation of geosyncline. As I told you that geosynclines were water bodies that were surrounded by rigid masses, and it happened that the sediments were brought to the geosynclines by various agents of denudation or erosional agents, and due to these sediments they put enormous amount of pressure on the geosynclines and then they underwent a sort of subsidence. So, this was the basic formation of geosynclines. So, lithogenesis is related to the creation or the formation of geosynclines, which is characterized by sedimentation and subsidence. And once the force is generated due to subsidence, a stress or motive force is generated, which brings the 2 forelands surrounding the geosynclines. These are the geosynclines and these are the forelands surrounding the geosynclines. When there is subsidence along the geosynclines, the forelands are brought towards each other due to a stress force, and which leads to the crumbling and buckling of all the sediments or squeezing of all the sediments into the mighty fold mountains. So, Kober also explained that when the maybe there is all the sediments are formed into the fold mountains, or sometimes there is a median mass, that is there is a plateau formed in between and only the marginal areas are folded. So, what happens that when the stress force is not that high, or when there is a decrease, when there is a wide geosyncline, then only the marginal areas are folded. And what happens, the central area or the median mass, he called Swiss change Burge. He gave the terminology of the median mass or the central area which is not folded, but though it is uplifted, it is a kind of tableland, and it is the median mass or Swiss change Burge, and the marginal areas which were folded, the marginal areas of the geosynclines which underwent folding were called Ranketten by him. So, these are the terminologies you should remember: Swiss change Burge, the median mass which is not folded, which is in the form of a plateau or a tableland, and Ranketten, which are the marginal ranges. So, you can see there are several examples of median mass, and with the help of Kober's theory, he explained all the alpine fold mountains of Eurasia. Like you see, examples of median mass are found, like Hungarian median mass is between the Carpathians and Dinaric Alps, Tibetan plateau is between the Kunlun and the Himalayas, Iranian plateau is between Zagros and Elbrus, Mediterranean Sea is between the Pyrenees and Atlas, Anatolia plateau is between Pontic and Taurus mountains. So, these are several examples of median masses, and you know the median mass can be in the form of plateau, can be in the form of sea also, like Mediterranean Sea I explained, it is between the Pyrenees and Atlas. Now, the third stage, this stage was the second stage when the mountains were forming, and the third stage is the glyptogenesis, which sees a very gradual rise in the mountains, and it also experiences the denudation by fluvial and other processes, and there is a kind of lowering of the height of mountains. So, a kind of balance is maintained in this glyptogenesis state, where there is a very gradual rise in the mountains, but they are again levelled or lowered by the agents of denudation, and the height of the mountain decreases. So, this is the last stage of Kober related to mountain building. You see in this figure I am showing, like in this figure you see these, this is the geosyncline part, and these are the forelands. These are the forelands surrounding forelands or rigid masses surrounding the geosynclines, and from the forelands sediments are brought over here, and sediments are accumulated in the geosynclines, and after that it subsides, and then a stress force or a compressional force is generated, due to which the marginal ranges in this figure are getting folded, and there is a median mass in between the two marginal ranges. And as I told you, if the geosynclines are narrow, then maybe entire mass will be folded like this here also, and there will be no median mass. This is also one case. So, in this figure it is very clear. Now, coming on to the evaluation of Kober's theory, there are several criticisms related to Kober's theory. His force of contraction or the compressional force generated due to subsidence was criticized by various scholars, who said that such force is not sufficient, that may cause mighty fold in the geosynclines and give rise to fold mountains. These are not that much sufficient force, and besides there was a scholar Suez who viewed that only one side of the geosyncline is moving and the other part is stationary. However, his the concept of Suez was further refuted when plate tectonics theory validated the Kober's concept that both the forelands were moving, because in case of plate tectonics it was found that both the forelands in case of Himalayas were moving, like African landmass and Eurasian landmass, both the landmasses were moving and the mighty Himalayas fold mountains were formed in this way. And there is one more criticism related to Kober's theory, like he was able to explain the only those mountains which had the east-west axis, like Himalayas or the all the alpine fold mountains of Eurasia, but he was not able to explain the mountains which are having the north-south axis, like the Rocky Mountains of Americas. But still, in spite of all these flaws, Kober's theory is still considered very important, because he gave the concept of geosynclines in the origin of or the formation of mountains, and the concept was carried forward by other theories that came later and validated the concept of geosynclines and the origin of mountains from geosynclines. Now, you will get questions in exams related to this, like critically explain the Kober's Orogenesis theory of mountain building of Kober. So, you will explain all the 3 stages with figures, and then you will explain the criticisms, then you will fetch good marks, because and the figures I will show after explaining the Holmes theory. If time is left, I will show how to draw the figures, rough sketches you draw, and you will fetch good marks in exams. Now, coming on to the second theory, that is thermal convection theory of Holmes. Holmes gave this theory of convection currents, thermal convection currents, in the year 1928-29 in his book on principles on geology, principles of geology. Now, these thermal convection currents were mainly responsible for orogeny or the formation of mountains, and these thermal convection currents were originated in the substratum. You know, as we go below the crust, temperature increases at the rate of 1 degree centigrade per 32 meters below the crust. So, there is rise in temperature when one goes below the crust, and so this rise in temperature becomes so much in the substratum that convection currents are generated. And one more thing related to convection currents, these currents are not generated everywhere below the crust, but only below the continental crust and the equatorial crust, where there is a thick continental crust is thick. So, the temperature gradient or the decrease of temperature below the crust is greater, and because of equatorial bulge also the decrease of temperature below the equator will be greater. So, convection currents would be generated below the continental crust or below the equatorial crust, and these will ascend, these will move like this, ascending convection currents, and when they reach the top, that is the crustal part, they will not be able to break open the crust in a single time, but they will follow a cyclic path like this, they will turn like this, and once when their energy will decrease, then these will come downwelling like this. So, the convection currents would rise in the substratum, upwelling convection currents, and these will again turn like this, and when they reach the mantle part, upper mantle part, there the density of the upper mantle is very high. At that point of time, it will not be able to penetrate through the mantle. So, it will again turn this way. So, it will follow like this, ascending, and then it will follow a cyclic path, turn like this, and again ascending. So, this is the process, and you see in this figure, you see below the continental block there is ascending convection currents, and these are moving, and once their energy decreases, they are coming down as downwelling convection currents. And when they are upwelling at that portion, like at this point, there will be faulting of the crust, a crack or fault will develop, and then there will be also, if the crack is developed, then it can also give rise to volcano at this point. So, these are the tectonically active zones, and when at the portion where the convection cold currents are downwelling at this portion, you see this is a region of compression, and this is where the geosynclines are there, and then due to compression of the forelands, if there is a geosyncline over here, then it will undergo squeezing of all the sediments and formation of fold mountains at this portion. And at this portion, when the crust is breaking and a crack or fault is developed, it can also lead to opening of a new geosyncline. And here where there is already a geosyncline, the compression force will lead to the formation of fold mountains. So, this is the basis of Holmes convection current, where he said that the convection currents are the forces which are responsible for orogenesis, and not the stress or the motive force of as suggested by Kober. Now, there are three stages of formation of mountains in case of Holmes. The first stage is similar to Kober's, which is related to the formation of geosyncline sediments and subsidence, and when the sediments reach greater depths, the temperature increases and they become hot and metamorphosed, their density increases and mountain roots are formed, and this stage is of long duration. Now, the second stage is when the convection currents become more rapid, descending convection currents applies maximum compression force, and the sediments of the geosynclines are folded and mountain building starts in this case. Third stage is the stage of waning convection currents. There is gradual disappearance of the uprising currents, and the energy is stored or accumulated below the new thicker crust, which is the mountain roots, and then descending currents also begin to disappear, and the eclogite or which has gone to greater depths has a tendency to rise. Thus, there is a volcanic interruption or intrusion in the fold mountains. So, the highest altitude is reached in the third stage as per Holmes. So, these are the three stages of Holmes theory of mountain building. So, when the question comes, you will give all the three stages and give the merits and demerits or the criticisms of the theory. First, we deal with the merits of the Holmes convection current. It is that the view that the convection current was the force related to the orogenesis or the convection current was more scientific compared to the stress force or motive force of Kober, and he gave a scientific explanation to the continental drift theory only and explained the formation of Rockies and Andes mountains. He explained the formation of plateau between two fold mountains. As I have already told you, if the geosynclines are wide, then there is a plateau formed as entire sediments are not folded in the form of fold mountains, only the marginal areas of geosynclines are folded, and there is a plateau or median mass formed in between, and in case of narrow geosynclines, all are folded, all the sediments are folded. He also explained volcanic intrusion in the fold mountains. Now, demerits of Holmes theory is that since the mountains were formed out of sediments, so mountains should have sedimentary rocks, but there was granitic structure also which was folded, and Holmes could not explain that why there is granitic structure in the fold mountains. He could not explain the fold mountains of circum-Pacific ring or those along the edges or the eastern and western parts of Pacific Ocean, and no fold mountains were found in the equatorial belt. Although he said that there is in the equatorial belt convection currents are formed, but there is no fold mountain in the equatorial belt which he could not explain. And many scholars also suspected the validity of the convection currents, and mid-oceanic ridge is also not continuous in Pacific. If he explained the Rockies and Andes mountain of Americas, then he should have explained that the mid-oceanic ridge is also in the Pacific Ocean is continuous, but it is not continuous exactly. So, in this video program we have studied about the definition of mountains, different forms of mountains and different theories related to the origin of mountains or the building of mountains, like Holmes convection current theory and Kober's mountain building theory, and we have also dealt with their demerits or criticisms. I can show with the help of a diagram. This is a geosyncline, and these are the forelands. A and B part are the forelands, and from here sediments are brought to the geosynclines, and the geosynclines after sedimentation in the geosynclines it undergoes subsidence, and a stress force is generated due to which the sediments are folded. Sometimes only if the geosynclines are wide, the marginal areas are only folded and there is a median mass formed in between. And so, in this way you should not be worried. With the help of diagram or simple sketches you can fetch good marks. And in case of Holmes convection current theory also, you can explain that below the continental crust there is upwelling cold convection currents, and here there are various landforms like volcanoes, opening of geosyncline, and then convection currents move this way, and here if a geosyncline is there, both the downwelling convection currents applies pressure and the mountains are formed. In similar way, if the mountains are if the geosyncline is not that wide, then all the sediments are folded, otherwise there is a median mass. So, in both way, with the help of simple sketches you can draw. And so, friends, keep watching, and in the next video program we will deal with plate tectonics theory. Thank you.